Hey guys, Dr. Brown here, and tonight we're working a little bit of a geometry problem. I ran across this the other day, and I don't know about you, but I search around for different problems. I'll see a problem, I think, oh, that's kind of cool, and then I'll go try to work it, and then come back to that, and then look and see if it's correct, or at least if I can get the same answer they did. So I guess we both could, in theory, miss it. All right, this problem, you have the two concentric circles. And the shaded area here, or the hatched area, the area of that shaded region is 7 pi. And then there's a chord that comes along that touches the outer circle, but it's tangent to the inner circle. And the question is, what is the length of chord AB? Okay, all right, let's work first with this shaded area. We know the area of that outer circle, if we said, okay, that's the center of this thing, we'll just let that be big R. That's the radius of the larger circle. And I'll let little r be the radius of the inner circle. Small one. So we know that the area pi big R square, can you see that? All right, pi R square minus the area of the inner circle, pi little r squared, is equal to 7 pi. Now I can divide pi out of all sides, and I end up with the larger radius squared minus the smaller radius squared equals 7. Or if I were to say, well, let me just for the moment solve for one of those, the larger radius squared equals 7 plus the inner radius squared. All right, let's hold that thought. All right, so I need to rewrite some things here. Since this chord AB, since it is tangent to that inner circle, then I know that tangent point is the farthest down point, right? So that means it bisects AB in half. So that's that inner radius. So now if I were to redraw my outer radius to this point where AB is touching the outer circle, that's also still big R. It's the radius of the outer circle. So what did I just do? Oh, we created a right triangle with this length here being AB divided by 2. Oh, what was that do for me? Well, I have AB over 2 squared plus the inner radius squared, and that equals the hypotenuse, which in this case is the outer radius squared. Well, we just solved for the outer radius. We know it's 7 plus r squared. Let me just substitute that. 7 plus r squared, or the smaller radius squared. Well, I'm trying to solve for AB, that chord. I can subtract the little small radius squared from both sides. So that eliminates it here and eliminates it there. So now I have AB equals 7. AB over 2 squared equals 7. If I take the square root of both sides, that cancels that out. So I have AB over 2 equals square root 7. Now if I multiply both sides by 2, that cancels. Now I have AB equals 2 square root 7. I thought that was a cool problem. Not a long video, but it did make us think about how to understand the inner and outer circle, understand how we calculate then the area associated with what was given, and then understand how tangent how this tangent point bisected the chord, and that allowed us to understand we had AB over 2, and a Pythagorean theorem then could help us solve for this. Okay, that's all for now. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying, okay? And we'll talk to you guys next time. Thanks.